67. Same thing we did yesterday. We're going to follow that list. We had a list of things we had to follow. Here's your list. Here's your guidelines. We're going to verify if it's normally distributed or if n is greater than or equal to 30. We're going to state your hypotheses, both. Find your level of significance. We're not going to do your test. We're going to find your p-value. We're going to use your p-value based on this. We're going to make a decision, and we're going to interpret your decision. And then I'm going to show you in the calculator how to do this as well. So after we walk through this one, we're going to put it in the calculator. All right, so I'm on 367. According to a study, the mean cost of a bariatric or weight loss surgery is $21,500. You think this information is correct. It's a statement about the population. You think it's incorrect. You randomly sample 25 bariatric patients and find that the mean cost of their surgeries is $20,695. From past studies, we needed a population standard deviation, so it was known to be 2250. The population is normally distributed, because we don't hit a 30 in this, and we want to know, is there enough evidence to support the claim? If I use the word support, is my claim going to be HO or HA? Which uses the word support? HA. So, let's find the claim. The mean cost of the surgery is what?
21.
Oh,
the surgery? Oh, it's the 20,000.
The information they give us. The mean cost of your surgery, $21,500.
Well, for the population.
This is for the population. Only I think they must have this backwards. Uh-huh. Why is this backwards? So tell me, guys, what? Okay, hang on. Let's look at this again. All right, they're going to turn this around on you. They're going to tell you that the mean, this is going to be your HO. However, they're going to use your claim. You think this is incorrect. Normally, they don't do it this way, but they're turning this around on you. They're going to say, you think this is not $21,500. This is your claim. According to a study, they really didn't make a claim. They just had information there. So your claim is, it's not going to be $21,500. So we're going to reverse the logic a little bit on this. So this is, well, hang in there. This is your HA. This is your HO. Remember, this is your P right here. Whether you use a support word or a reject word. Now, why is this different than before? Usually somebody claims, a manufacturer claims, something claims. This one said this was a study. I don't agree with the way they worded it, but they want us to support a claim. Your claim has to be your HA if you use the word support. So the claim is coming from you this time. You claim that this is not true. You read this study and you say this is not true. So you're going to test this. And you want to support your own claim in this case, don't you? If you make this claim and you want to support it, your information has to support this. So what tail test is this? Two-tail test. Good. Two tails. Pull out your sample information. You have a sample data. You have your sample mean. And from past studies, you have your population standard deviation. Okay, we're going to challenge this claim at a level of significance of 0.05. We're going to use your p-value to test this. All right, so first thing we need to do is find your p-value. So we're going to find, how do we find a p-value? Find your z-score. Good. So let's use your z-score. Remember, you have a sample, so you're going to have to change your standard deviation. So plug this in. Your sample mean minus your population mean over your standard deviation divided by the square root of 25. And they come out with a z-score. Let's just pop to theirs. negative 1.79. How do I find the area?
Chart.
Chart. Okay, go to the chart. Look up negative 1.79. God bless you.
God bless you. All right.
Negative 1.79.
Point.
367. Okay, go 4 positions. Now, this is 2 tails. What do we do with the 2 tails?
Double it.
Double it. Good. We're going to multiply this by 2. So you're going to double this. So here is your new p-value. This is your p-value. Good so far?
Yes.
All right. We're going to test your p-val, just like that chart over there. P-val against level of significance. We tested your p-vals yesterday. Fill this in with zeros, make them the same positions, and drop the decimal point. Is 734 greater than?
Yes.
So what's the decision you're going to make?
Fail to reject.
Fail to reject what? The little o. We're going to fail to reject HO. Now, let's interpret this. Bring this back. Come to your HO. If we fail to reject this, don't we have to agree with that?
Mm-hmm.
If we don't reject it, then can we support this claim? No. If we fail to reject this, we're going to have to go with this. So let's follow your chart. Come to your chart. Your claim is HA. You fail to reject HO. This is how I want you to start your interpretation. There is not enough evidence to support the claim that the mean cost of a bariatric surgery is $21,500. Okay? It's a little backwards the way they did this. I'm not fond of the way they set this up, but sometimes it works that way. Okay? Good? Now, got a calculator handy? All right. I'm going to put this in your calculator. This is the best test of all. Go to stat. Go to test. You're sitting right there. This is a Z test. Didn't we do a Z? And we're testing because we're testing your hypothesis. You can tell that this is a Z test. See these 3 little symbols down here? Yours is going to match one of them. So we're going to come down here. We don't have data. We have statistics. So we're going to enter your population mean. Your population mean is this one. Okay, your population standard deviation they gave you in the problem. Your sample, what's your sample mean? 695 or 45? 965. And how many in your sample space? 25. Okay, your tail. Do you see where it says U dot dot? It says U dot dot, not equal to, less than, greater than. You're going to just follow your symbol. Here's your U. So we always follow the symbol for the HA. So you're going to take this piece right here, which is the not equal. You're always going to follow your HA. This is your tail. Notice that none of them have an equal sign in it. So for this guy, we're sitting right there at the not equal. Calculate. Here's your Z-score. Look, didn't they find the same Z-score?
Yes.
Round the Z-score to 2 decimal positions. Here's your p-val. See the word P? P stands for p-val. There's your p-val. All we're testing with right now is your p-val. So we could bypass all of this stuff right down here. We still need to make a claim. We still need to make a stat. We still need to interpret. But they're going to find our Z-score. They're going to find your p-val.
Say if we got the HA wrong, like the equal sign or the less than greater, is it gonna mess with the whole problem?
It will, because then you're not looking for the area. In this case, you want 2 times the area. You need this to be a 2-tail test. If you do just a greater than, you're only getting 1 tail of this, and it's probably going to change your situation a little bit. And sometimes you're going to find, like, the book will do a less than, but it's going to show up on the right-hand side somehow. So I usually think that's probably like a misprint somewhere, but it happens. It can happen. Because your data that you pull out from your sample could not be a good representation of your population. That's something that you have to go back and look at and say, is this off because my sample was off, or is this off because it's so far away from the claim? Those are things that you're going to look at. All right? So we're good with that? Questions? All right, you guys are going to try the next one. All right, so the claim. Damani, what's your claim?
Me equals
Okay, is this your HO or your HA? Aaron, what's your HA? Does not equal 3.3. What tail test do you have? Two-tail test. So now,
It's just 3. That means it's just 3.
The sample's changing up. The claim.
It's great.
great, but remember, they kind of did this backwards this time. Sure. Okay, they went back to the regular one with 3. All right, hang on. Wait, sorry.
So this whole thing.
No, you're right. You're fine.
Yeah.
You're fine. Okay. Pull out all your sample information. Do your z-score. 3.3 minus 3 over, I'm just taking a shortcut here. Standard deviation of how many in your sample? 25. What did you find your z-score to be?
3.
3 and negative 3, right? It came out to be 3. So we know it's a negative 3 and a 3. You have to find your area. So it's easier to look up the negative 3. If you look up the positive 3, could that little tail be 0.99 something or other? You have to subtract it from 1. So look up the negative 3, 0.0013, and make sure you times it by 2. Now the reason yours didn't come out when I went over there is because you probably didn't do normal CDF. You gotta do normal CDF, not PDF. I'll come back over there. Because it should have come out this, Aaron, it was yours. When we looked it up on your table, it was fine, but your calculator wasn't. Okay, so now, compare your p-val to your level of significance. Don't forget to fill it in. And this is less than or equal to. So when your claim is your HO, and you're less than less than your level of significance, what's your decision? Reject HO. There's enough evidence to reject the claim that the mean cost of your surgery, the mean recoup time of your surgery is 3 years. You got to make sure you have that interpretation. Did you try it on your calculator?
No, trust it.
Can you do it?
Oh, it's so much nicer. Watch. It's the first one there. It's the first one. Hit stat. Go to test. It's the first one. You're testing your claim with a z-score. Plug them all in. Your mean was 3. Your standard deviation was 0.5. Your sample mean was 3.3. Your n is 25. You're still a not equal. And there it is. There's your z-score. There's your p-val. It already multiplied it by 2. If the rounding is off, it's just because your calculator rounds a lot better than we do. A little bit more exact. Look, there's your sample mean. It just repeats these things. It repeated your claim. Yes.
How did you know that, like, does the U not equal 3 follow the HI?
Well, U not equal to 3 is the HA. That's where we got your two-tail test from.
I mean, like, on the calculator.
On the calculator, that's this one right there, the not equal to. You're gonna follow the tail, or whichever inequality is for your HA, because that's where our graph comes from, your HA. That's where we look for the area under the curve. Now, if it was a less than, you'd put a less than here. Greater than, you put a greater than. It's going to follow this sign. So this one says U, there's your U, is not equal to 3. So this is going to say U is not equal to, there's your 3 right here. So that's your statement. U is not equal to 3. If it said U was less than 3, it would be this. U is less than 3. That would still be an HA, wouldn't it? With no equal sign, we would follow that tail. It follows the tail. It looks the same exact as your HA does. Same exact. And it avoids you having to do your z-score, find your p-val, multiply it by 2. All you have to do is test and set it up right. Okay? Are we good with this?
Yeah. Nice.
Nice. Okay.
Not that.
Yeah, you're real nice. Here's your assignment.
Oh. Boy, you just stole my soul.
Okay. Yeah, about 10 minutes. And then about 10-15 minutes tomorrow. Aaron?
His IQ just dropped.
Your calculator more
So we can't do it in the calculator?
You can't do the calc. You still have to lay out your sketches and everything else. Let's go to normal CDF. So we said negative 9 to 9. Negative is different, come on. Negative 3. Sometimes, I don't know, maybe there was something in front of it when we did it before. Sometimes if you don't clear your calculator, something comes out. You know, when you put your divide in, maybe it gives something other symbol in here, but that would be that times 2. Yeah. And that would have worked. I don't know what was in there. Clear it out each time before you name it. If you have any questions, call me over. Yeah. Okay, so where are we? Alright, so you're comparing your p-val. So you dropped your decimal. It is 461 bigger than 100 and greater than. So you know what the equal to? The equal to goes on your left hand side. Because it has to be as extreme or more extreme. So when we say as extreme, that's the equal part. More extreme, that's the less than part.
You usually don't say like more extreme or anything?
No, we looked at that before when we looked at the less than or equal to. What happens in your less than or equal to is if it's as extreme, it's equal to. If it's more extreme, it's even smaller. So that's where the less than or equal to comes from. That's the only one that gets the equal sign. Keep those charts handy. I gave you that chart. Keep that chart handy when you work on these.